All right. Hello, everyone. Today we are on day 3, which is just practice for proof. So there's no notes today, but I did upload a extra practice worksheet for you guys for proof. So for those of you who just want to see more of them or want more practice, I uploaded that to Schoology. Now, this is not something that you're turning in, but I figured what I would do is do some problems from that worksheet in this video. Probably, I think I haven't decided yet. Well, we'll see how it goes, but I might just do all of them. That way, if you are working on that extra practice, because we're not going to go over that in class, so this would be a good resource for you to come watch this. Obviously, you're going to skip around because you probably don't have questions on every problem, but just doing the practice with you guys so that you can see how you would attack those extra practice problems. Again, since it wouldn't be something that we would do in class, right? We would go over homework in class, but not really these extra ones. So without any further ado, I'm just gonna jump in. So this is that day 3 more proofs practice worksheet. That's a mouthful, more proofs practice. And just start working through some of these proofs. Now, keep in mind, right, that there's more than one way to do these proofs. So maybe the way that I'm approaching the problem is different than how you would approach it. So this is just one technique. Now, if you watch this video and maybe you're looking at it and you used a different technique for your problem, that's okay. Your doesn't mean yours is wrong, and if you're confused and you think maybe yours is right also, you can always come by during office hours and we can look through what you did for these problems. Okay, so here we go. Okay, so like I said, we're on this day 3 more proofs practice. Remember, this is not something that you're turning in. This is just extra. But I'm just going to go through these problems. So we'll start with just number 1. All right. So let me get all ready here. Okay. So first off, just like with any proof, you want to pick the side that looks more complex, and then that's the side that you're going to work with. In this case, it looks like very obviously that the left-hand side is the more complex side. So I will be simplifying from this left-hand side, and my goal is to make it look like the right-hand side. So just like we did in the other video, we're just going to work vertically. Remember, you are not to work sideways. We're not going to touch that cosecant squared piece at all. It stays exactly as it is. We are taking just this left-hand side and working straight down in order to get it to become cosecant squared. Now, you may need more space for this. Get a separate sheet of paper. It says so right in the instructions. All right. I'm going to hopefully try and make it fit in this little square that I'm given. Okay, so the first thing that I see is secant squared theta minus 1. That is one of our Pythagorean identities. So the first thing I'm going to do is I'm going to go ahead and use the Pythagorean identity to change secant squared theta minus 1 to tangent squared theta, because that's what it's equal to. So I'm rewriting the top as just secant squared theta over, and then this becomes tangent squared theta. All right. So the next thing that I'm going to do is I am going to separate this into 2 fractions. So I'm going to separate it as secant squared theta times 1 over tangent squared theta. All right, next I'm going to change tangent squared theta to its reciprocal, which is cotangent. So the next step is going to be still secant squared times cotangent squared. All right, and now I'm going to do that technique that we talked about the last time, and I'm going to rewrite this so that everything is in terms of sine and cosine. So secant squared is 1 over cosine squared. Cotangent is cosine squared over sine squared. All right, now I can simplify. So I see that I have cosine over cosine, so I can simplify those out. And then what I'm left with is just 1 over sine squared. And then using my reciprocal identity, 1 over sine squared is cosecant squared theta. So check, I have now proved that that left-hand side is equal to cosecant squared theta. All right, moving on to number 2. Again, I'm going to choose the left-hand side because this is definitely more complex. So I am working with the left-hand side and simplifying down till I get 2. That's my goal. All right, so first things first for this one, I am going to have to expand my binomials, right? So I have to, you can either write these as 2 separate parentheses and then FOIL, or you can use that technique that we talked about since the beginning of the year. I ran it up here again. So a plus b squared equals a squared plus 2ab plus b squared. It is one of the nicest and fastest things that you can use for expanding a binomial squared. All right, so here we go. First one becomes sine squared theta plus 2 sine cosine plus cosine squared. All right, so that's the first one expanded. Plus, now I'm going to do the second one, sine squared minus 2 sine cosine, and then plus cosine squared equals. All right, so I've now expanded those two binomials. Now I can see what I can start to simplify. All right, so first off, I have a 2 times sine times cosine, and then a minus 2 sine times cosine. That makes 0, right? A plus 2 and then a minus 2 of the same thing. Those are like terms, so we can say that they add up together to make 0. So now I'm left with sine squared theta plus cosine squared theta plus another sine squared theta and then a plus cosine squared theta. All right. Now this now sets me up to using my Pythagorean identities. Sine squared plus cosine squared equals 1. So this sine squared plus cosine squared equals 1. And this sine squared plus cosine squared equals 1. So I end up with 1 plus 1, and as we all know, 1 plus 1 equals 2. And now I have proven that the left side is equal to the right side. All right, moving on to problems 3 and 4. All right, so number 3. This one is kind of interesting. You really can choose whichever side you want to for this one. I'm going to choose to do the right-hand side. But there is a case to be made to do the left-hand side. But since we normally are doing the left, I'm going to do this one with the right-hand side. So my goal now is to get 1 plus cosine over sine to equal cosecant plus cotangent. Okay, the first thing I'm going to do is take this fraction and I'm going to split it into 2 fractions, right? So when you have a fraction and you're adding the numerator, you can rewrite them so there are now 2 separate fractions. So this can be rewritten as 1 over sine theta plus cosine theta over sine theta, right? So I just kind of split that in 2. All right, now I'm going to use my reciprocal identity to change 1 over sine to cosecant. And then I'm going to use my the ratio identity, sorry, I couldn't think of that word, to change cosine over sine to cotangent, because cosine over sine is cotangent. And guess what? That's all I had to do. So that is number 3, and I'm done. All right, moving over to number 4. This one I am going to choose to do the left-hand side because being raised to the power of 4 is larger than being raised to the power of 2. So this one looks like it does have more that I can do with it. All right, so the first thing I notice is that I have something to the 4th minus something to the 4th. This can be factored using difference of perfect squares. So I'm going to factor. This becomes cosine squared minus sine squared times cosine squared plus sine squared. All right, so that is just factoring using the difference of squares, right? Difference means subtraction, square means your numbers are perfect squares. You just take the square root of each piece, one gets a plus, one gets a minus, and then you put them inside, right? So we did talk about that. That was one of our techniques I told you was very helpful for the future. All right, now I'm going to use my Pythagorean identity that says cosine squared plus sine squared equals 1. So this ends up being cosine squared minus sine squared times 1, which we know is just going to give us cosine squared minus sine squared. I don't need to write the times 1. We all get it. Okay, so now from here, this isn't exactly my my Pythagorean identity, but I can use a Pythagorean identity. So this one's a little tricky, and there is a couple ways you can do this. All right, the way that I'm going to do this is by replacing sine squared with 1 minus cosine squared. All right. And the reason I'm doing that is because when I look at the right-hand side, I notice that I want to keep the cosine. So the cosine piece is what I want to stay, but I need to get rid of the sine piece. So I'm going to replace just sine squared theta, right? So I'm just replacing this piece right here with the 1 minus cosine squared, or sorry. Yeah, that's right. 1 minus cosine squared theta. All right, so now rewriting it, I have cosine squared theta, like the original one, minus 1 minus cosine squared theta. All right, so I just replaced that. So I used my Pythagorean identity and I replaced sine squared with 1 minus cosine squared. All right, now I'm going to distribute my negative, because remember this was a negative out front, so I need to make sure that I distribute it to each piece of my parentheses. So this is going to then give me cosine squared theta plus 1 plus, oops, sorry, minus 1. Woo, Miss Lossley, duh. Minus 1 plus cosine squared. All right, now I can combine like terms. I have a cosine squared plus another cosine squared. That becomes 2 cosine squareds. And then that minus 1, and then I am exactly where I needed to be. So I am now at 2 cosine squared theta minus 1. All right, so whereas we didn't touch the right-hand side, we did use it to guide us to what we were trying to do, right? So I knew that I needed to keep cosine squared, but get rid of sine squared. So that is how I knew that I was going to replace the sine squared with the 1 minus cosine squared. All right, so whereas you can't touch the other side, you can use it to kind of guide you to where you need to be. All right, moving on. So for problem number 5, all right, I am going to, so this one there's 2 different techniques. It would be safe to say you could use the right-hand side or the left-hand side. It doesn't matter. I am going to choose to do the right-hand side, I think. So I think I'm going to do the right-hand side of this problem. Yeah, why not? Why not? Let's try. Now, I might decide when I start doing this one that I don't like working with the right-hand side, and then I restart my problem and go back and try it again with the left-hand side. That might be what you do also. Maybe you pick a side and you don't really get anywhere, so then you change your mind and you go back, you can try the other side. I might end up doing that with this one. I don't know yet. I'm trying to kind of think through and see what I can get, but that 1 minus cosine is really throwing me off. So it's okay. We're just going to try. So I'm going to attempt the problem by using the right-hand side. And let's see if we can get there. So first thing I'm going to do is I'm going to rewrite this in terms of sines and cosines. So cosecant is 1 over sine plus cotangent is cosine over sine. Okay, so we have a common denominator. So we have 1 plus cosine theta over sine theta. All right, and we need it to be basically upside down. Huh. Give me a second. Miss Lossley is stumped on this one. Well, the only way, so the thing that I want to do is I want to get the sign in the top. All right, so to get sign in the top of my fraction, that means I have to multiply top and bottom by sine, and that will get me a sign in my numerator. Now, is that going to be the best method? I don't know yet, but I'm going to try it. So I'm going to multiply top and bottom of my fraction by sine theta. All right, so that's going to give me sine times 1 plus cosine theta all over sine squared theta. Okay, okay. I can see where this is going now. We're getting there. Okay, so now I can use a Pythagorean identity, all right, because I have sine squared on the bottom. So I can change sine squared, just like we did in the last problem, to 1 minus cosine squared. So I'm going to rewrite this. So I have sine theta on top with the 1 plus cosine over sine squared is going to change to 1 minus cosine squared theta. Okay, from here, I need it to just be 1 minus cosine, right? There's nothing squared in the denominator on the left-hand side. So I'm going to factor 1 minus cosine squared. This is the difference of perfect squares. 1 is a perfect square, cosine squared is a perfect square, and there's a minus in between. So this is factorable. So I can rewrite it. So I still have my sine and then 1 plus cosine on the top. But I'm going to factor that 1 minus cosine squared to 1 minus cosine theta times 1 plus cosine theta. So I use that difference of squares factoring technique. All right, from here, it's now pretty simple to see what we can do because we can cancel out something from our numerator and our denominator. So 1 plus cosine and 1 plus cosine cancel. So what I am left with is sine theta over 1 minus cosine theta, which is what I wanted to get in the first place. So I am now done with this problem. All right, moving on to problem number 6. So that was definitely a tough one. All right, there is another technique that you could use for problem number 5, and that's working with the left-hand side. So if you wanted to do this one working with the left-hand side, what you have to do is multiply the top and the bottom by the conjugate. So 1 minus cosine, its conjugate is 1 plus cosine. So you would have to, so if you were going to attempt to do problem number 5 using the left-hand side, you would have to multiply both top and bottom by 1 plus cosine. All right, and then that is going to, that should then help you figure it out. So it would basically would be like working backwards from the one that we just did, right? So you would multiply 1 minus cosine times 1 plus cosine. That gives you 1 minus cosine squared, which turns into sine squared. Then you can simplify, and then you can separate your two fractions. So that would be the technique. So that would be called using a conjugate, right? And that is definitely a helpful technique. So by choosing to work with the right-hand side, I didn't need to do that. I did, however, need to multiply top and bottom of my fraction by sine. And I knew to do that because if I looked at the left-hand side, I noticed that there was a sign on the top of my fraction. The only way to get that there was to multiply by sine on top and bottom. But that's something that a lot of people probably might not think of. So using the conjugate technique is also very helpful. All right, but yeah. So moving on to problem number 6. This is an easy one to figure out what side to work with. I'm definitely going to be working with the left-hand side for this one. And first thing I'm going to do, working with the left-hand side, is to rewrite everything into like kind of separate fractions, right? So I'm going to, because like I have sine over cosecant, like I know those go together. So I'm going to rewrite them like this. So I have sine theta times 1 over cosecant theta plus I have cosine theta times 1 over secant theta. All right, now I'm going to use my reciprocal identities to change 1 over cosecant and 1 over secant to their reciprocals. The writing is so slow. All right, so here we go. We have, this becomes sine times sine plus cosine times cosine. Sine times sine is sine squared. Cosine times cosine is cosine squared. All right, so now that the writing is all caught up, We can use our last identity, so sine squared plus cosine squared, that's a Pythagorean identity, and that equals 1. Sine squared plus cosine squared equals 1. So we end up with 1 equals 1, which is exactly what we wanted. All right, so I'm actually going to stop the video here. So this is the whole front page of the worksheet. So I'm going to kind of stop here, and then I might make a video of the back side of me working through the back of the worksheet if people decide, like they tell me they want to see that. But yeah, so hopefully that was helpful. If you have any questions, please come by during office hours and let me know. All right, bye guys.